Okay, ninth graders, today you are going to be doing a lab on pulleys, and obviously we're not here in class to be able to do it and actually get the experience of pulling a string that's connected to pulleys and a weight, but we've got a simulation here that you can practice on. So the first thing you're going to do is you're going to open up this document, and this is found on Classroom. And then once you have this document opened, you're going to go to the Pulley Lab Simulation website. So we click on this. And this is what you see. You can see a crate being connected to some pulleys with some strings. And then there are some ways to modify that. So a couple of things over here, you see the pulley diameter. We're just going to leave that as it is. The height to lift is set at 0.14 meters. We're going to leave that as it is. And then the load is 10 newtons. Now you can change that if you want to. You can make it heavier or you can make it lighter. But whatever you do, keep it the same for every trial. So if you want to just leave it at 10, go ahead and leave it at 10. But if you switch it to, say, 7, then leave it at 7 for all the trials. Okay, so back to the lab here. The first direction says the weight of the hook weight is given on the simulation as the load, and it's set at 10 newtons right now, which is what I just talked about. You can leave it at 10, change it to something else, and this is also known as the output force. It is the force that the machine, the pulleys, are exerting. Like I said, keep this the same for all trials. So whatever you choose, you can write it in right here. Likewise, the height to lift is set at 0.14 meters. Again, leave it here for all of the trials. That's right here, 0.14. Now, both the output that's the output distance. So both the output distance and the force out, you can just record all the way down before you even do anything. So the output distance is 0.14 in this column. The output force is going to be whatever you chose it to be, and right now it's set at 10 newtons all the way down this column, and you don't have to even do anything yet other than write those down. All right, so now we're going to look at 4 different situations. We're going to look at the single fixed pulley, where you just see a pulley right here. We're going to look at the movable pulley, the single compound, and the double compound. All right, so we're going to start out with a single fixed pulley. So it says switch it to single fixed, and then you're going to put your cursor on the little hand here and click and drag. Oops, I'm not on single fixed. Okay, you're going to click and drag down. Now notice it's not doing anything because I'm not applying enough force. Now eventually I'm going to keep dragging. It's going to get big enough, and then it's going to start to move, and I let go and it moves. Okay, don't mean to give anything away there. All right, so then you're going to record whatever that force was that it had to be in order to make it move. And then you're also going to record the distance that it traveled. So the distance pulled, that's right here. That gives that, once it's done pulling, it will give you that information. All right, and then the last thing you're going to do, according to the instructions here, is you are going to calculate the mechanical advantage by dividing the force out by the force in. And you've practiced these types of problems already. Mechanical advantage equals force out divided by force in. Now hit the reset button in the lower right and change the pulley system to movable. So you've done all your recording, you did your calculation. Now we want to reset, so you can hit either one of these buttons, it doesn't really matter. But you're going to switch it to movable. And now the only thing that's going to be different is instead of pulling down, you're going to have to pull up. Right? And so pull up until it starts to move again, record all the data, do the calculations, and then you're going to switch to single compound, and then you're going to switch to double compound. And again, do steps 2 through 5, again for each of those different types of pulley systems. All right, so then that data table will be completed. Then there are some questions. So did you notice a difference between the mechanical advantage with a single fixed versus a movable pulley? What happened to your input force as you added pulleys in? What happened to the input distance that you pulled through as you changed pulley arrangements? And then what's the relationship between how hard you had to pull, or the input force, compared to how far you had to pull each time, which is the input distance? Then some more questions here. And then finally, I've got a prediction question. Now notice the one we didn't do was the triple compound. Well, let's just, take a second here and think, if I have a 10 Newton load and I set it to triple, how hard will I have to pull? And I want you to guess at that. Don't actually pull on it, but just guess. And use number 7 as a way to know what the mechanical advantage would be, and then figure out what the input force would have to be. And then actually set it up and try it and see if you're right or wrong. All right, that's it.